This short video will cure cost curve confusion. So in this video, we'll carefully distinguish between the short run and the long run. We are in the short run. That means there's an input that's fixed. It's usually floor space or acreage, something along that line that we talked about. And then there's a variable input that becomes more and more inefficient as you put more people into that same space. In this video, we'll go to extremes to untangle those cost curves that we've been looking at. You have a marginal cost curve, and there's various influences that affect the marginal cost curve, and it affects the average total cost curve. And how do you disentangle that? Well, this is what the video is about. So when we get done, we'll conclude that the marginal cost curve has its shape, and the example I'm using is the Nike swoosh shape. It comes about through specialization. That specialization will drive the marginal cost curve. It drives the average total cost curve. We'll also look at diminishing marginal returns to the variable input. And the returns are diminishing or decreasing because, again, there's a fixed input, and that is the constraint eventually. As you add more and more labor, you have this constraint of a fixed input. Again, that tells us we are in the short run. And so this diminishing marginal returns will drive the marginal cost and the average total cost curves. And by the way, I'm calling this specialization. If you examine some other literature and you talk to economists, sometimes they'll talk about increasing returns to the variable input being labor, for example. But a lot of people are nervous about using the same words, increasing returns, because we have that concept of increasing returns to scale, and I don't want to get to increasing returns to scale or decreasing returns to scale in this video because I'm focusing on the short run here in this video. So we have specialization, and that is an example or a form of increasing returns to the variable input. Then there's diminishing marginal returns to the variable input. Well, that's decreasing returns to a variable input. So there's some semantics going on here. Don't let that fool you. Then finally, we'll talk about fixed cost spreading, and fixed cost spreading drives the average total cost curve, but not the marginal cost curve, because the marginal cost curve just looks at the change in total costs, and your change in total costs is your increased quantity. Can't change because of fixed costs, because fixed costs are fixed. So that's kind of straightforward, but it is confusing to some people. It could be very confusing. But once you say it, you'll say, "Oh yeah." Okay. Then when I get through that, so I'm going to explain this using paper and pencil, and then what I'm going to do is I'm going to flip over to a Mathematica app and show you a pretty neat way of modeling these cost curves. Okay, our first task is let's establish ourselves here. So here we got the marginal cost curve. It's the Nike swoosh. Now I've been telling you that this part is caused by specialization, but specialization actually continues further along, but it gets overwhelmed by diminishing marginal returns to the variable input. That's where this comes in. And so the two are acting against each other, but eventually diminishing marginal returns to labor wins out. Now, let's look at the situation where we have specialization, we have fixed costs, we have no diminishing marginal returns to labor. So I'll spell it out. If that's the case, we're going to have an average total cost curve that keeps coming down, a marginal cost curve that keeps coming down. So the marginals below, it keeps pulling down that average like we talked about. And you're going to have an average variable cost curve that looks something like this. And so there you have it. You have specialization. Look, the specialization is continuing and continuing and continuing. Now, what would happen if we had, well, when we add, we know what will happen now. Take this scenario, and instead of no diminishing marginal returns of labor, get rid of that no out there, and there we have the Nike swoosh. Now, let's look at what happens when we have fixed costs. So we're going to have fixed costs. There's no specialization. and there's no diminishing marginal returns. I'll call it DMR for short here. And what that would look like is this. We would have an average total cost curve that comes out like this, right? Because there's that spreading of fixed costs, but because there's no specialization and no diminishing marginal returns, you're going to have a marginal cost curve that's flat. So there's no initial specialization winning out. There's no diminishing marginal returns taking place and winning out eventually. I mean, it'll win here. The specialization will win here, and diminishing marginal returns would win here, but it's not happening. There is none in this example. Then there's one more case that I want to look at, and that would be fixed costs. We have no specialization, and we have diminishing marginal returns. What would that look like? Well, that would look like this. Put my cues here. We would have a marginal cost curve that's going up because there's no specialization, nothing bringing it down like we had over here. So you have a marginal cost curve that comes up. You're going to have an average total cost curve that's going to look something like this, an ATC. It's going to go up a little bit, right? And then you're going to have a average variable. It's going to come something like this. You're going to have, it's going to come up asymptotically or getting closer to this because of the fixed costs. But there's no specialization, so there's no downdraft here like we see here. And the marginal cost curve comes up, so we got no specialization. We have diminishing marginal returns. It takes a little while, so here we got diminishing marginal returns. This has got to swoop up eventually. And it's the diminishing marginal returns to the variable input that eventually puts the brakes on the size of most businesses. So you might ask, well, what stops businesses from getting bigger and bigger? Well, the answer is the short answer is there's a lot of businesses out there that are big, but there are certainly a ton of businesses that are very small. And what puts the brakes on businesses in general in terms of size? It has to do with diminishing marginal returns of labor. So that's one of the key aspects to growing your business. If you want to grow your business, you got to overcome those diminishing marginal returns to the variable input. So before we go on, let me move on to a Mathematica app that will show us these relationships. I think it's pretty cool. So here we have a Mathematica app. Let me show you. Come up here, Wolfram Demonstrations Project. It's basically an app. It's called Short Run Production and Cost Curves appropriately. So this is a Mathematica app. Come down, let me show you the credits there. It was contributed by an individual called Tom Crehan. And what we want to focus in on is this. Now, there's some bars here to move. And before we go further, I got everything set in the middle here. And what we have is increasing returns. That's basically specialization because we're in the short run. It can't be increasing returns to scale. It's increasing returns. It's basically the specialization concept. And you can move it to zero specialization to maxing it out here, and you can actually show those controls, break it out, the numbers that are underneath it. And then we have diminishing returns, and I set that at the middle, and we can have zero diminishing returns to the labor, and then we can max it out here. And then we have fixed costs, zero fixed costs to high fixed costs. So notice right off the bat, I got everything down, set in the middle as a benchmark. And here we have quantity, and then here we have X. X is basically labor in this case. And so here we have our total product curve. Because remember, when you have labor going on this axis and Q on this axis, it's our total product curve. You can see a little bit of indentation, a little reflection here, right? That's the effect of specialization that's coming about here, increasing returns. And then eventually diminishing marginal returns will win, and you actually will produce less. So that's why here it says product function here. Now let's look at the cost curves. The green, if you highlight the green, it says ATC, average total cost. You ought to be able to pick these out even without the labels. at least in this form, marginal cost curve, and then an average variable cost curve there. So now let's go to various scenarios. Let's say we had no specialization. 0. Look what happens. We have a marginal cost curve that never drops down. The Nike swoosh is gone. It's just an upward movement here. Okay? We have fixed costs, so your average total cost curve is getting spread. And so you can see the difference between here. This is the average total and the average variable right here. So there's the spreading. You can actually see that going on. But you have diminishing marginal returns that eventually overwhelm, in terms of the average total cost, overwhelms things. And so your average total costs are coming up because of that. Let's have no diminishing marginal returns with specialization. Well, that's an odd one. This is an odd looking graph. So you have specialization but no decreasing returns. And so look, your average total cost curve keeps coming down from that specialization. So like I said, specialization is normally present. It diminishes. I should be careful with that word. It actually is reduced, specialization. But it's there. But remember, when it swoops up, the average total cost is U-shaped normally. It's because of the diminishing marginal returns wins out. But I set diminishing marginal returns to 0. So, and then here's our marginal cost curve straight down. And that reflects increase to specialization and no diminishing marginal returns. Now let's see, if we were to set them back to normal and reduced fixed cost, what would we see? Well, we basically, look, we have a marginal cost curve, an average total cost curve. I mean, things look fairly standard in this situation. And what we're seeing is diminishing marginal returns. This is programmed so that diminishing marginal returns eventually wins out, is driving this marginal cost curve. So what would you have if you had no fixed costs and no diminishing marginal returns? There you'd have some strange looking cost curves. And this is, maybe this will give you a better feel for why we use the cost curves we do. They are a bit contrived, but nevertheless, they're extremely helpful because a lot of the concepts that we're talking about, it shows up in the real world. Not as simple as what we're portraying it, but look, we're dealing with models, and models are a simplification of reality. Now, in reality, we're not going to have 0 fixed costs, and we're not likely to have 0 diminishing marginal returns. So this is not a likely scenario for our cost curves. We're likely to have diminishing marginal returns. We're likely to have specialization, and we're likely to have fixed costs. And there you go, standard cost curves. So I hope this helps with the confusion of cost curves.